Bismillahirrahmanirrahim. In continuation to the topic of force for IGCSE and O-level student, we are discussing the alternative to the practical topic. Here we have a 13 number question on the exam style questions. If physics class is asked to investigate the extension of a stretch spring, you will be supplied with a spring, a clamp stand, a half-meter ruler, is set square, and a hanger with 100 grams weight and a sticky tapes. Describe how you carry out the experiment. So stretching is spring safety, eye protection must be worn. In the case of spring snaps, arranging a steel tape spring as in figure 1.52. So this is the way the steel spring is here, and we are hanging weight here, and the ruler is there for measures. So this is mm scale, because this is centimeter, so the one small unit is in millimeter. So read the scale opposite the bottom of the hanger. Add 100 grams mass on one at a time, thereby increasing the load by step of 1 Newton, and take readings from the scale after each one. Enter the reading in the table for mass up to 500 grams. Note that at the head of the column or row in the data table, it is usually to give the name of the quantity or its symbol followed by name and the unit. So this is load, scale reading, and total extension. So this is load, scale, and extension will be used for every load. So we will increase the load from 100 grams to 100 grams, and then we'll read the reading, and the extension from the previous reading we'll write here. So the suggestions such as precaution you would take to achieve a good results. Some of the precautions: avoid the limit of proportionality, hang the weight gently, record measurement once the oscillation dampens, avoid air friction in the vicinity. So these are some of the precautions. The other precaution could also be considered. The table below shows the extension of a spring with the increasing stretching force. Plot a graph with extension m per mm along the x-axis and stretch the force on the y-axis. So this is force and this is stretching. So draw the best line, draw the point, and mark the region over the proportionality holes. Indicate the limit of proportionality. So this is the limit. So here we have more extension with some force. So this is force and this is stretching estimations. So with minimum force, the stretching is much higher. So this is a non-linear behavior. So the limit of proportionality is at this point, or beyond which there is no certainty. So this can be considered as limit of proportionality, beyond which the non-linearity appears. Calculate the gradient of the graph. The gradient of the graph is this. So force per mass per extension is the gradient of the graph. So dx by df. So this is because here in this y-axis we have used x, and here we have force. So in this way the gradient is dx by df. So this is 1 millimeter per Newton. Determine the spring constant. Spring constant is F upon x. So this is 1 Newton per meter, and this millimeter can be converted into meter. Is this 1000 millimeter by 1 meter, and then this can be divided, and this results is 1000 Newton meter is the proportionality constant. The question number 15: in an experiment to investigate the law of moment, a half-meter ruler is balanced at its center as shown in figure 1.542. In this figure, a mass of 50 grams, 100 grams, and 150 grams are placed in turn at the position given in the table below. Complete the table, filling in the value for the unit at the head of each column: force, distance from the pivot, and moment of this. So mass is 50 grams and the force is 0.5 newtons. So the ruler reading is 5 here. So this is 5 centimeter and this is 20. So this is 20 distance and this is 0.5. So this is multiplied, the force and distance is multiplied to have obtained this 10. So 50 mass and this force 0.5 and the ruler's reading is 10, so it gives 15, and this is 15 multiplied by zero point 0.5 is 7.5 is the B reading, and then 0.5 with 15 centimeters distance pivot from the pivot, and then this is 10 distance, and this is 10 into 5 is 0.5, and this is reading is 20, and from this rulers 20 is basically the distance is 5 because it is placed at 25, so this is 5, so at 30 the distance is 25 to 5 is 5 centimeters, so this is gives 5, and this 35, this is at distance of 5 from the pivot is 10 because the 25 is the pivotal point, so this is 10, so at 40 it gives 15, and this is 15, so we can see that which one is balanced form is this is A and F, this is A and F, this is 10 newtons and this is 10 newtons on one side, and this 10 newton is on the other side, so this is clockwise and this is anti-clockwise. Similarly for C and E, C is 5 newton on one side, and E is on the other side because this is 25 on the other side, anti-clockwise and clockwise, so this gives a balance condition. So that's all from this first topic.